Hello there, good to see you again. What we're going to do in this video is investigate the rate of change of the slope of the graph of f of x equals sine squared x at x equals 0. And remember, the slope of the graph is another way of saying the slope of the tangent line of the graph. So looking at our graph here, now when x equals 0, to the left we have negative slopes and to the right we have positive slopes. So the slopes are definitely changing, but what is the measure that we need to look at in order to look at the slope of the rate of change in the slope? And as we look at this, we know the slope itself is f prime, and the rate of change means I'm looking at a derivative. So it's the derivative of f prime, which is f double prime. So the second derivative tells us information about how the slopes of the tangent lines are changing. And we want to know what's happening at 0. So the answer to this question is when we substitute 0 into f double prime. So you have a little bit of work ahead of us here. Now for the function sine squared of x, we know in order to use derivatives, we like to write this as sine of x quantity squared. So that's going to be where we start. Sine of x quantity squared. So f prime of x is equal to, well, the derivative of something squared is 2 times the something times the derivative of the inside. And there is basically nothing to do there. There is no way to rewrite that in order to move forward. So what we're going to do at this point is treat this as a product rule. Now I'm going to treat 2 sine x as the first function and cosine x as the second function. Now what I like to do to organize my work is to take the derivative of each piece and put it pretty close to the original function there. So the derivative of 2 sine x is 2 cosine x, and the derivative of cosine x is negative sine x. And then remember, the derivative of a product is the crisscross pattern that I'm about to show you here. So it's the derivative of the first times the second. So we have 2 cosine x times cosine x plus the first times the derivative of the second. So we have 2 sine x times negative sine x. And yes, we are going to clean this up just a little bit here. So this is 2 cosine squared x minus 2 sine squared x. Remember, that's our second derivative. That's the function that we're looking for here. So then at 0, well, what's happening here? I have 2. Now, cosine of 0 is 1. So it's basically 2 times 1 squared. Sine of 0 is 0. So that's 2 times 0 squared. And that just evaluates to be 2. So that means at that moment, the slope is changing by 2 units for every unit that we increase on x. And as you look at this, it makes sense because the slopes are going from negative to positive, so the second derivative at 0 really should be a positive number, and this confirms that it is positive. So there we have it.